And one of the things we need to pay attention to when we have a derived class is initializing it properly. And a constructor for a derived class compared to just a constructor for any other class has at least one additional consideration that it needs to be careful about. How do we initialize the members in the base class, right? So we're inheriting from the base class, we're getting all the support from the base class. It might even be that the person, the coder implementing the derived class didn't implement the base class and may not know all the subtleties of how it works. And so, and there could be private members in there that need to get initialized in just the right way. And so how do you, as a implementer of derived class, guarantee that everything in the base class is getting set up properly? This is a big concern, right? If we're going to copy a bunch of code from someone else, we'd better use it properly. So there are some possible options that we could just come up with on our own so far for initializing base class members. And at some point in your life, you're going to be tempted to do one or all of these things I'm about to describe. And really, there's only one good way. So option one is that I could manually initialize all of the base class members in the derived class constructor. And so what that would look like here, over here, I have a little simple piece of code. I have a class A where I have private field A and public field B. By the way, recall that if we don't specify at the beginning of class A, then by default fields are private. So A is private and B is public. Okay, and then I inherit in B from A. B is derived from A. And then B has its own field C. And then in B's constructor, I could say A equals 0 because A comes from class A. B equals 0, again, from inherited from class A, and then C equals 0. A good thing about this approach is that, B is taking responsibility for initializing everything, including the parts of class A. So that's good. But the bad thing is that it doesn't work. There's a syntax error. I can't initialize member A that I'm inheriting from class A. And the reason is that this is private. It's private to class A. And yes, class A is a part of class B, but I'm still not allowed to access its private parts. And so this will fail. This is a syntax error. So the most I would be able to initialize would be B and C, and that's just not good enough, right? So this approach doesn't work, right? It fails to and another thing it fails to do, my second bullet point here, is it fails to reuse code properly, right? We've already written a constructor for A that initializes A to 0 and B to 0, and I'm not even reusing that code. So this turns out to be bad for two reasons. It has a syntax error, that's a really bad reason, and it doesn't reuse the code in the base class as well as it should. So option two is that, seeing that I really should be trying to use this constructor in class B, and I've changed this a little bit to have a couple of constructors now. What I could try to do is from within B's constructor, call A's constructor to get it to initialize my fields. That seems like a pretty smart thing to try to do. So at the beginning of B, I put in a call here to a constructor of A, right? So I know that the constructor of A can take no arguments or 2 arguments. And so here I pass in the 2 values that I want A and B, members A and B, to get initialized to. And this looks like I'm on the right track, because now I'm reusing this code, and this constructor can initialize a private variable because it's part of class A. Okay, well, the problem here is that this does not do what you think it does. This does not initialize a part of object B. The part of object B that contains object A, it doesn't do that. What this constructor call says to do is to create a new object A, a temporary object A, and initialize it. And then this temporary object A will get destroyed when B's constructor ends. So anytime we kind of explicitly call a constructor, we're actually making a new object. We're actually kind of telling the compiler, make an object, a temporary object on the stack. And so this is not at all what we want. It looks like what we want, but it doesn't do what we want. But it is the right idea. We want to call this constructor. Okay, so we need yet a different approach. This approach does not work. And by the way, I have made this mistake at times in my life since, first learning C, of thinking, oh, well, let me just call this constructor within B, and that's going to do what I want. And it's always an annoying moment when I realize, nope, I'm misunderstanding how these constructors work again. I can't just call them to get them to run on object B. It doesn't work that way. So don't make mistakes I've made before. So option 3, the recommended option, and really the only correct option that we're going to see here in this video. What we need to use is a feature of the language I've kind of been showing you and hinting at a little bit in my previous videos. You might have gone and read about it. We need to use what's called a member-initializer list. So a member-initializer list is a comma-separated list that comes between the parentheses of a constructor and the body of a constructor function. So here, after B, open close parentheses, I put a colon, and then before the constructor begins, before this open brace, in between here, I can have a comma-separated list of initializers. And this is the correct way to call a base class constructor. So when I initialize an object of type B, then what this member initializer list says is the first thing you need to do is call the constructor from A, passing 2 integers, values 1 as arguments, to initialize the sub-object A. This tells the compiler exactly what we want to have happen. We want the parts of object B that come from class A to get initialized with this constructor A11. And this will do what we want. This will initialize those parts of B. In fact, we don't have to call this constructor. We could put any constructor from A we wanted here. We could put the default constructor, A, open paren, close paren. That would work too. And a lot of times objects have multiple constructors and you just have to pick the one you want, right? And we could even do this on a non-default constructor in B. So any constructor in B, because it derives from A, it should have a member initializer list, and it should say explicitly which constructor in A to use to initialize the parts of A that B shares. This is a special language feature that allows us to explicitly call a constructor in the base class. Now, we can also use this member initializer list to initialize other member variables. And so we can actually turn this into a comma separated list with initializations for member variables as well. And that's something we're gonna commonly do. And you've seen me do that already in some slides, and you might have wondered, why am I doing that? Well, a member initializer list is just a really convenient and clear way to initialize things before a function starts running. And so we have to use it when we're dealing with derived classes. And that's why I've kind of waited till now to tell you about it, because derived classes necessitate that you do this. Here's that code up close, but let's say I also want to initialize C in my member initializer list. Then right after the parentheses for the constructor B, and this is an out of class definition for constructor B. Since I'm not showing you the whole class, my style is on these slides that if I'm showing you a function out of a class declaration, then I write it to look like an out of class definition. And so I'm just saying in class B, B has a constructor, a default constructor that takes no arguments. And then the way to initialize its members, right? So we have this colon that tells us this is a member initializer list. First, call the constructor on class A. And we're going to call the parameterized constructor that takes 2 integers. And then initialize field C with the value 0. And so this syntax C, and then in parentheses 0 is just a way of saying give C, integer value C, the value 0. Okay, and then once I get into the body of B, then I can do more elaborate operations like print out the value of B if I want to. Okay, so the member initializer list, What it should include, first, the base class constructor if needed. This will initialize base class members. Okay, then the initialization of any other member variable within the class, the derived class, to a constant or to some value passed in as a parameter. You don't want to do a lot of heavyweight calculations in here. You can't have a for loop or something like that in a member initializer list. You can only specify exactly how to initialize that member variable using like a simple expression or a parameter. Another thing is any member variable of a class that's a reference, it should also be initialized in the member initializer list. And then in general, the order of the initializer list should match the declaration order of fields. That's the recommended thing to do. And you'll actually get a warning from the compiler if you don't do that. Now, I just want to point out this idea of initializing a reference, because so far I've intentionally avoided this in all of my previous code I've shown you. I've avoided putting a reference in a class, because in order to do it properly, you have to use a member initializer list. You can't do it any other way. But it's perfectly legal to have a reference inside of a class. The challenge is that as we've said before with references, when you declare a reference, you have to say what it references at that moment. You're not allowed to say it later. And the problem is in a class declaration, there's no way to say what a reference variable is referencing, right? There's no way for me to put that in here because I don't know yet, right? I'm just declaring a class. I'm not saying, and then I'm going to instantiate later, and not until I instantiate it do I know exactly what maybe the member variable is referencing. So it creates a little chicken and egg problem. But I can have a reference as a member of a class. And when I do that, I have to initialize it in the member initializer list. So for example, in this case, the constructor of A will take a reference as an argument. And then in my member initializer list, I'll say that A is actually this member A is referencing this reference that I pass in. And now this sets everything up properly. That's the only other way. That's the only way you can do it. And so now in this example of main down here, I declare a variable X, integer variable X, and then I create class A, and I make this instance of A reference X, right, by passing in X as the argument to its constructor. And so that means the A inside, this little a inside of class A is going to refer to X here. And so when I say A.A equals 5, I'm really changing X. And then when I print out X, I'm going to see that it has the value 5. You can kind of extrapolate from here, but we can have any type of reference we want in an object. The only trick is you need to establish that link when you construct the object. Okay. One other kind of point that's worth making at this, now we've talked about member initializer lists, but do you really have to use them? What if we forget to call the base class constructor? Well, it's not really the end of the world. If you omit a base class constructor call, the good news is the compiler will automatically call the base class's default constructor for you if it has one. And this kind of makes sense because if we don't specify default constructors, then we know the compiler makes them for us and calls them for us. And so it's kind of no different with class inheritance. Like if I make class B here that inherits from public A, and I don't specify a constructor for it, then the compiler will make a default constructor, and in the process will actually call, in its default constructor for B, it will call the default constructor for A. In the same way we've showed here, right? We're never going to see the code because the compiler makes it for us, but basically there would be a kind of a member initializer list in which it would invoke the default constructor for A. So if you do nothing to construct your derived objects, the compiler will step in and use the default constructor on the base type to help you construct it. So that's good news. So like here in main where I create this object little b, then the field b.a will be initialized because the compiler will invoke class A's default constructor. Ironically, the field b inside this object, b.b, will be uninitialized because we wrote no constructor, and therefore the default one from the compiler will do nothing to initialize it. Now, here's a more subtle situation. Let's say we don't write a default constructor for B, and there is no default constructor for A. Remember, a default constructor is a constructor that can be called with no arguments. And since we make A's constructor here take an integer, then it doesn't have a default constructor. So, and then when we make class B, we don't give it any constructor at all, so the compiler makes a default one for us. When we try to instantiate an instance of class B, the compiler is going to realize it doesn't know how to initialize the parts of B that come from A. It has no default constructor, and that is a syntax error. The compiler doesn't know what to do here. There's no way for it to make A by default. There'll be a syntax error, and the only way to fix it is for us to either add a default constructor to A, or to add a constructor to B that explicitly calls the non-default constructor for A. So this gets a little bit hairy, right? As long as we have default constructors sitting around, it kind of all works the way you might expect it to work. If you don't have default constructors, you're going to start getting syntax errors when you build these derived objects. Okay, so in summary, we should initialize base class objects properly when we make a derived class. Any derived class constructor needs to worry about how its base class members get initialized. And the key problem are private members that a derived class is not allowed to access. The only way they can initialize them is through a constructor. So we need to use a member initializer list to explicitly call a base class constructor. If we don't specify one, the default constructor, if it exists, will be used automatically. Okay, but if there is no default constructor, that's going to lead to a syntax error. So the best thing we can always do is when we make a derived class and we implement this constructor in the initializer list, we need to explicitly construct the base class, by specifying which constructor to call. Member initializer lists are also the preferred way to initialize references. And they're also the preferred way to initialize members of a class to a constant or something very simple.